When we see just about any form of professional motorsport, you'll probably see images of race engineers sitting behind an array of monitors looking at all of the data in real time as the car goes around the racetrack. And while this has been prohibitively expensive, over time we've seen the technology mature and the cost for these systems come down to the point where they are achievable for some club level and semi-professional motorsport teams. We're here with Ty from Motec Australia to talk a little bit more about telemetry. So before we actually get into the telemetry, just so our viewers have a bit of an idea of your background, you're working for Motec in Australia at the moment, but you've actually got a fairly broad history in motorsport, both in Australia as well as in Europe. So can you give us a bit of a background? Where did you get started with your Australian motorsport career?
Yeah, look, straight out of school, I got involved with a supercar team in Australia. And from there, that just led my passion for motorsport. Worked up through the ranks in supercars before I travelled to Europe. Did a couple of years in F1 before I came back to supercars and then on to Motec.
Okay, so not a lot of people probably make it to the pinnacle, which is F1, and you're working for Williams there. What sort of roles were you doing?
So I was an electronics technician, so I managed everything on the vehicle from looms to sensors, calibration and gearbox control.
And then on race weekends also data management, data engineering?
Correct, yep. So I'd be second back up to the data engineer, observing telemetry primarily, more of the health of the vehicle. The data engineers would manage the engineering side and we'd manage the health side.
And now, data, regardless of how we're getting, whether it's live via telemetry or downloaded in the pits after a session or after a race, is really critical to optimising both the chassis and the driver, as well as monitoring the engine and making sure that that's going to be healthy. But of course, being able to do this live with telemetry just adds another element of being able to pick up on things instantaneously while the car's out on the track. Before we get into the actual system and what you're looking at there, can you tell us what's actually necessary in order to get telemetry to the trackside?
So primarily it's that connection wire, and obviously you can't have a cable follow the car around. So there's various options in terms of radio equipment that can send it over air, and that's the primary use these days.
So for our own system that we're using in our own sort of club level motorsport, we're using the Motec T2 system with a 3G modem. So where's the sort of pros and cons of using a cellular connection versus a radio connection?
So there's pros and benefits is with the VHF or the lower end radio, generally you'll need good line of sight to the car. So when you go to circuits with blind hills or crests, sometimes you can lose connection, you'll get holes. But the 3G, 4G obviously uses cellular connection technology. It's got a much larger throughput, so you can send a lot more data at a higher rate, which is almost similar to looking at log data. But then you obviously have some limitations depending on the track and phone coverage, but generally, where there's a phone that'll work, you'll get it.
Unfortunately, in New Zealand, we do tend to find that a lot of our tracks seem to be in cell phone sort of black spots, which doesn't help. So obviously, if you don't have a cell tower, you don't have cell coverage, as you've said, your chances of getting telemetry via cell phone or 3G, 4G is going to be non-existent. So that's where that radio comes in. So sort of radio is the predominant means with some of the professional teams?
Back in the day, yes, they were. A lot of high-end stuff these days have moved away to the 3G, 4G, just purely for the throughput. But for the radio side, you can still get a chunk of data through at lower rates and still make good calls on what's happening with the vehicle live.
Now, one concern is obviously if you're sending all of this data from the car to the trackside, obviously teams are secretive. They don't want other teams sharing their information or seeing what's going on the car. So how is security managed with a telemetry system when all of the cars may be sending this data?
Yeah, so with the T2 server, we have the capability to receive one car or multiple cars. And we have, in the dash, we have capabilities to send the data encrypted. We can unencrypt that on the pit side with T2 server and then re-encrypt it. So if we want to distribute that data to various teams, race control, broadcasters, we can set up individual security so that they can only see the channels we want them to see.
So obviously the teams there want complete visibility of all of the channels, but as you mentioned there, maybe guarding some of the channels that they don't want going out. So in terms of race control and the broadcasters, so could you give us an idea of how those channels are being managed and what those two areas are seeing, like the broadcasters and race control?
Yeah, so obviously the teams want to have everything that they're sending From a broadcaster point of view, they generally will use them for the on-screen graphics on TV, or they might publish it to their website live.
So you're talking overlays there where we see RPM, speed, brake and throttle traces?
Right, the basics, the vehicle speed's obviously the big one. And then they can do a comparison, so they can have multiple cars up and see where the drivers are hitting the brakes or changing gears.
Now, another thing we've seen, at least in the Australian Supercars series this year, is the ability to actually send information back to the car in terms of flag colours. If something's gone on track, maybe the driver hasn't actually come upon a marshal point, but you can actually send that information back to the dash. Can you tell us a little bit about how that works?
Correct. So we've been developing our race manager, which allows the flag marshals to send in a flag state that they're howling out, and we can then display that instantly on the team's dash. So not only is it the flag points, we can also send blue flags, black flags, and text message. So we can put a visible text message back on their dash.
So like pick up dinner on the way home from the track?
That's right, yep.
All right, so getting back to once we've actually got that data, as a race engineer, obviously you might have potentially hundreds of channels to sift through, and I'm guessing you really want to break down to the most important things. So for you as a race engineer, when a car's out on track, looking at the telemetry, what are the key sort of aspects you want to keep an eye on?
So the big ticket ones are your health of the car, so your engine vitals. They're probably the main one, but then you're looking to what the vehicle's doing from an engineering point of view, whether it needs some damper, spring rates, things like that. So when the car comes back, you've already got an idea of what you need to change or what you need to go looking for when the driver's back.
I think it's important to sort of understand that race weekends are really busy, and in most classes your actual running time out on track is going to be very, very limited. So this is all just about optimising the track time, so you're not actually wasting time doing a spring change during a session necessarily. You can be prepared.
Correct, yeah, that's right. So before the car comes back, you've already got an understanding of what the car's doing. The driver can give you feedback over the radio, so that you've got the mechanics ready or the parts ready to make the change, and exactly right, maximise your track time.
Now, coming back to those engine vitals and looking after things like maybe gearbox and differential temperature as well, again, there's still going to be a lot of stuff to monitor there, but you can set up alarms as well, so you don't necessarily need to be looking at a particular channel. The software will alert you if something goes out of range.
Correct. i2 has the capability of setting up any sort of alarm and trends, so you can see if something's heading up, or you get a pre-warning before it actually gets to a trigger point.
The other aspect here, and this is something we've actually been using a little bit ourselves, is using telemetry for driver training, where you've got multiple drivers, and this really comes down to one of my favourite aspects of any data logging or data analysis package, I should say, is using a reference lap, potentially from a faster driver, and being able to see a variance or where another driver is faster or slower. So can you tell us how you can actually do that live?
Yeah, correct. So within i2 you can have a logged file uploaded, and you can do it with a telemetry file as well. But as the vehicle goes around a lap, it can overlay directly over the top of that, and you can see live, whether they're slower into a corner, out of a corner, braking markers, and you can give that feedback over the radio. Yeah.
I think this technology obviously is still relatively expensive. It's definitely not something that every club level racer should have or is going to have, but as we progress through and become more professional and get into the more professional sort of races as well, it is that sort of technology that can make a real big difference to both the reliability of the car as well as the performance of the car. So thanks for giving us some insight into what goes into that, Ty. Cheers for your time.
Cheers, thank you.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.